Hello everyone, welcome to this AIT Tech Talk. Today's topic is wide bandgap power devices adoption gathers momentum. So let's move this to more into this topic. Uh, so abstract of this topic is that as power electronic continues to extend into renewable energies markets, smart grids, smart homes, transportation, and electric and hybrid electric vehicles, EV and HVs, and other emerging industrial and medical applications, more designers are attracted to the wide band gap WBG power devices. Example: silicon carbide (SiC) and gallium nitride (GaN). In the past few years, engineers have spent time understanding the virtues of these emerging power devices and their drawbacks. Example: reliability, cost, availability today, and many analysts believe that the engineers are transitioning from education mode to implementation mode. According to the research, Hewlett Development's technology and market analyst Hong Kong Ling were gradually going from the customer awareness and the education stage to the customer trial and adoption stage. This is especially true for silicon carbide transistors. Falling prices and increasing commercial availability of these devices multi multiple sources are the factors further accelerating the adoption of silicon carbide and gallium nitride power devices and a new application as well as existing ones like chargers for consumers and devices such as smartphones, laptops, TVs, etc. Finding from IHS market technology suggests that the global demand for silicon carbide and gallium nitride powered semiconductors will exceed US 1 billion mark in the next 5 years, going to approximately 1.32 billion dollars to in 2000 by 2022. IHS principal analyst for power semiconductors Richard Eden is projecting double-digit annual growth for wide bandgap power devices in the next 5 to 10 years. The primary catalyst for these expected growth includes DC-DC converters for EV powertrain and onboard chargers for HEVs and EVs. By comparison to the silicon, this is the only this is only a drop in the bucket. Per Eulis report to the total estimated power semiconductor market in 2017 was approximately $30 billion by dominating by silicon. So analyst predictions in the next 5 years, IHS expects the compound annual growth rate CAGR for the of month of more than 20% for silicon carbide power devices. As this rate, the market will grow from the roughly $266 million in 2016 to approximately $1 billion in 2022. By 2020, Eden predicts that all Chinese-made DC-DC converters for powertrain and onboard chargers for HEVs and EVs will incorporate in SiC devices. Nothing but it is a silicon carbide. Likewise, the production of gallium nitride on silicon power transistors is rising, and the gallium nitride power modules are being to emerge. As a result, the IHS market studies suggest that sorry, uh, power devices will experience a CAGR, which is the compound annual growth rate of nearly 30% in the next 5 years. Laptops and TVs like IHS and Yole's optimist grow about the growth, especially for silicon carbide devices ULS business unit manager says that the total SIC device market in will be worth more than $1 billion in 2022. The analyst is predicting that the market adoption of the SIC power devices to experience a 40% of CAGR from 2022 to 2022. As standards are essentials to drive the adoption of new technologies, the Joint Electron Device Engineering Council JEDEC Solid State Technology Association has announced the formation of a new JEDC committee. JC70 WBG means nothing but is a wide bandgap semiconductor power conversion semiconductors. Cassidy, business development and programs manager for Wolfspeed says creating a clear creating clear universal standards is a key in advancing the adoption of WBG technologies. These are the new parameters which enable users to design SIC and GAN devices into systems of tomorrow's, thus creating a more energy efficient future. JEDEC President John Kelly adds the formation of the JC70 committee is the part of an ongoing effort within JDEC to extend our standard setting expertise to new technologies to meet market demands. Power semiconductors, uh, while applications like power factor correction, PFC, power supplies, and photovoltaic PV converters are currently driving the adoption of the SIC devices. Fut- Future growth in the adoption will be driven by XEV related applications such as the electrification of more automobiles, rails, and other modes of the transportation. According to Euless, the XEV charging the infrastructure market is growing and rapidly adopting the SIC devices. Leading this Chinese XEV supplier, Build Your Dreams, better known as BYD, has confirmed its use of the SIC device in its onboard managers. Similarly, in Similarly, in Europe, the Micropower Group and ABB has unveiled uh, industrial battery chargers based on the SiC devices. You can see in this graph, this is the market study by research firms. IHS Market Technology show that uh, gallium nitride device sales revenues reach $320 million by 2022. So the next slide is the more SiC suppliers. The number of SiC MOSFET suppliers has doubled in the past several years, and it's expected to increase as new fabulous suppliers of SiC power devices enter the marketplace. For easier entry into the SiC supply chain, researchers from North California State of University (NCSU) has developed a new manufacturing process of and chip design for SiC power devices. Process engineered for manufacturing SiC electronics and devices. Precise was developed with the support from the Power America Institute funded by US Department of Energy. Details of the processes were presented at the International Conference on Silicon Carbide and Related Materials 2017 in Washington, D.C. Until now, companies that have developed manufacturing process for creating power devices have kept their methods theoretic theoretically, making it difficult for other companies to enter the field, keeping the cost of silicon carbide devices high. Professor J. Balia, distinguished professor of electrical and computer computer engineering at NCSU and a fellow of the IEEE, believes that NCSU developed the precise address in this bottleneck with the bottleneck with the goal of lowering entry barriers for companies and increasing innovation. According to Professor Beliga, the goal is to lower the price on to the 1.5 times of the cost of the silicon devices. Hopefully, that will begin virtuous cycle. He says. Lower cost will lead to higher use. Higher use lead to greater production volume further reduces cost, and so on. And consumers are getting a better, more energy efficient product, states Professor Baliga. To implement the this process, the precise team is using the XFAB Texas foundry located in Lubbock. Currently, the process is using 6 in substrates. According to the Professor Baliga, the precise uh, process is available now for the commercial manufacturing of SiC devices at XFAB, has a yield of more than 90%. Researchers have already licensed to precise the process and chip design to one US based semiconductor company, and several other companies are in this discussion. In March 2017, this Flensburg, Germany based unit of Denmark, Danfoss, Danfoss's Silicon Power collaborated with General Electric, GE, to build SiC modules in Marquis, New York-based facility called Computer Chip Commercialization Center (Quad C). GE will supply the SiC chips for these modules aimed at PV inverters, EV, and other applications. With the partnership, the Danish company is hoping to become the world's leading supplier of silicon power modules, and the company has already employed already employed 11 engineers. Concurrently, Key is the SiC devices supplies the world's feed uh, ROHM semiconductor and STMI ST Microelectronics, Infineon, Microsemi Corporation, Genie SiC Semiconductor, and United States of Carbide, INC. Infineon Technologies announced that the production of its first 1200 volts cool SiC module uh, at the 2017 Power Conversion and Intelligent Motion exhibition. Additionally, the company is broadening the cool SiC portfolio and with various packages and topologies while extending the blocking voltage range. Similarly, ROHM semiconductor continues to expand its SiC portfolio with the addition of 1700 volts of MOSFETs and full SiC power modules, including the gate driver integrating circuits ICs. So in this picture, you can see the graph that predicts the SiC device market will grow more than $1 billion by 2022. Thank you.